So this lesson is going to be on determining the number of significant figures. Now, just so you know, significant figures and significant digits are the same thing. It just depends on what source you're using and how they describe it. So we already learned how to determine the number of significant figures in a measurement. Remember how we always read the equipment and report the digits that are known? And then we always include one estimated digit because that estimated digit has some level of uncertainty. So we always include that one extra digit. So let me give you an example. If I reached into my pocket and I looked in my pocket and I said, I have about $200. This is how I would represent that approximation value. I would represent it as 200 with no decimal place. But if I reached into my pocket and I saw two crisp $100 bills and I wanted to convey that I had exactly $200, I would represent it this way. So 200 with a decimal place. The 200 with a decimal point, rather, is how we can represent a more precise value. If I showed 200 without a decimal place, that is more of an approximation. There are less significant figures in this value than there are here. So in this case, all three numbers are significant to the measurement, and in this case, only the 2 is significant to the measurement. So here are the rules for determining significant figures. All non-zero numbers are significant figures, or sig figs. I'm just going to keep calling them sig figs. So if I gave you a number like this, 6.15, assume all of these numbers, by the way, are measurements. If I said I had a pencil that was 6.15 centimeters long, this measurement has 3 significant figures in it. Remember, significant figures are related to measurements, so I should have done a better job and went through and added some units to these examples so that you can clearly see their measurements, but just for the sake of learning, I'll just ignore that for now. For this particular number, I see 1, 2, 3, 4, 5, 6, 7, 8, 9 non-zeros. Therefore, I have 9 significant figures. If I were you in my notes, I actually would go through and highlight or underline all of these significant figures so that they clearly are marked in your notes when you're studying them. Here is the second rule for determining significant figures. Sandwich zeros are sig figs. So if I have zeros in between two non-zeros, okay, because the first rule is still a part of determining significant figures, I see 1, 2, 3, 4, 5 significant figures in this measurement. So all 5 of these digits, all 5 of these numbers are significant to a measurement. This next rule, the next few rules start to get tricky, and all the tricky rules have to do with zeros. Leading zeros are not sig figs. So whenever I am a leader of a line, I'm in the front of the line, so these are my leading zeros. And in this particular number, these zeros are not significant to the measurement, but these 2 non-zeros are, so this value has 2 sig figs. Here I have leading zeros, they are not significant to the measurement, and I have 1 sig fig. You should continue to highlight or underline the significant figures just so they stand out at you in your notes. So I'm going to now combine all the previous rules with this rule, and this is where it starts to get even trickier. Trailing zeros are not significant unless the number contains a decimal point. So a trailing zero is what I call a zero at the end of the number. Like if you're trailing in a line, you're at the end of the line. So this 5,200 value, it does not contain a decimal. So these zeros that are trailing the number are not significant. This number here, 5,200, has 2 numbers that are significant to the measurement. These other 2 zeros are part of the approximation part or are not significant to the measurement. Now, if I have a number that looks like this, 5,200 with a decimal place and 2 zeros after, I know that these are my trailing zeros. I know that I see a decimal place, just like this statement says. Trailing zeros are not significant unless a number contains a decimal point, and these are non-zero numbers, so all 6 of these numbers are significant to a measurement. This value here has a decimal. I see 3 sig figs. And this number here has 1 sig fig in it, and no, because it does not have a decimal place at the end. So again, I think it's useful to highlight the significant figures in the measurements so that they stick out at you. What you're looking for here is a decimal place. Now notice it doesn't matter where the decimal is. It can be in the middle of the zeros, it can be at the end of a number. It doesn't matter if the decimal is present. Any zeros at the end of a measurement are going to be considered significant to the measurement. Now in scientific notation, all the numbers before the X are significant. So we actually call this a mantissa, the numbers that come before the X. You don't really need to know that. I'm just letting you know it has a name. So if I have 4.83 times 10 to the 25th power, this measurement has 3 significant figures. This measurement, we have to think about 2 rules. One, all the numbers before the X are significant, and the fact that there's a decimal here with a 0 after the decimal, we would include that also in the rules for sig figs. Now, I have a note down here that says all sig figs must be retained when converting between scientific notation and long form, and we will talk about this in the next lesson over scientific notation. So it's important you know how to read sig figs because you're going to have to retain them as you're converting to and from scientific notation. We also have the scenario where if you have a measurement and it's not in reference to, if you have a value, if you have a number that is not in reference to an actual measurement, that value can have an unlimited or infinite number of significant figures. For example, if I say I have 3 pieces of chalk, well, there are 3. There's nothing uncertain about that. There is exactly 3 pieces of chalk. I didn't have to take a ruler and put it against the 3 pieces of chalk to make sure there are 3. I didn't have to put it inside of a graduated cylinder to measure it. There's nothing uncertain about that. So we would say that this value here has an unlimited or an infinite number of significant figures. That's usually when you're just counting something. So I think that it would be wise for you to go ahead and hit pause on the video and just try to go through these questions and try to figure out the number of sig figs. When you're ready to go ahead and move along with the video, unpause it and then check your answers. As I'm going to go through the answers now, I'm going to make sure to highlight these significant figures so that you can see which ones are significant versus which ones are not. So here are the answers. In this first value here, I see a 0 in the front of the number, and leading zeros are never significant in the value, so this number here only has 2 significant figures. And by the way, let's go ahead and assume all of these are measurements. I didn't put units behind them, I should have, but let's just assume that these are all measurements. In letter B, I see 3 significant figures. I see a decimal, and there are zeros behind the decimal. So anytime you have a decimal, the zeros that are trailing in a number are significant. For letter C, I don't see a decimal, and I see zeros at the end. So that tells us that 0 in the end, the trailing 0, is not significant, just the 4 is. So this value has 1 significant figure in this measurement. Letter D, I see leading zeros, and leading zeros are never significant. Trailing zeros are only significant if there's a decimal. And it doesn't matter where the decimal is, as long as it's present somewhere in the number, those zeros are significant. So watch, these are the 4 numbers that are significant to the measurement. Letter E, all 4, we have sandwich zeros, so no problems there. And finally, letter F, all of these leading zeros are not significant to a measurement. I have just 1 sig fig there. You're going to do the same thing. This is the actual practice box in your note packet. I hope you've been taking notes inside of your note packet. If not, go back and fill them in. But hit pause and practice these and then come back to the video when you're ready to check your work. But I'm just going to go ahead and click through them and give you little tips and tricks here and there if I feel like they might be confusing examples. The answer for number 1. Or letter A rather. Here's the answer for letter B. For C, there's no decimal here, so that's that 0 on the end is not significant. For this problem, the zeros on the end, the trailing zeros, are significant when there is a decimal present. Leading zeros are never significant. And remember, anytime we have scientific notation, anything that's part of the mantissa, which is anything before the multiplication symbol, is a significant figure.